Hello there. Thank you for clicking on this video. In this lesson, we're going to talk about solving quadratics by square roots. As always, like and subscribe if you find this video helpful. Drop a comment or question below and check out the other videos and playlists on the channel, including the practice set for this lesson so that you get a chance to practice the content that we go over. So the first thing we want to talk about is when can we use this strategy? So recall that a quadratic takes, or at least can take, the form ax squared plus bx plus c. And if you're not clear on that, please check out the video that comes before this one, which is just an introduction to quadratics. What are they? Okay, and the key thing that makes something a quadratic is this x squared term. So remember, terms are things that are added or subtracted, and so we essentially took our slope-intercept form of a line, the mx plus b, and we add in a quadratic term to that. So we have this ax squared plus bx plus c. Now, if I want to solve a quadratic equation for x, I need to be able to get the x by itself. If you think about what we do when we solve linear equations, we try to undo everything that's been done to the x to isolate the x. Now, this particular strategy of using square roots only works if b is equal to 0. Okay, and we'll talk about that a little bit at the end of this video. This is not going to be a super long lesson, so hang with me to the end. It only works if b is equal to 0. So let's just explore what that means. So we start off with ax squared plus bx plus c is equal to 0. And what I just told you is that this strategy only works if the b value is equal to 0. So you'd have ax squared plus 0x plus c. And of course, 0 times x is just 0. And then ax squared plus 0 plus c, well, there's no reason why we need to add the 0. And so we're just left with this ax squared plus c is equal to 0. Okay, or you could have like another number in there. Essentially what I'm saying is that it can be made to take this form. It doesn't necessarily have to look exactly like this. So this particular strategy only works if there's no x term. Okay, so remember I said terms are things that are added or subtracted, and what we're saying here is there's no x term. You also might hear there's no linear term. So when we're talking about lines, we talk about that mx plus b, that's the linear term, and when you get to your quadratics, we kind of change up the what we're using to represent the number part, but that's the linear term. Okay, so you might hear that as well. So this strategy, very narrow application, it's only going to work if you don't see anything attached to an x. So the x term or the linear term is absent. You can see an x squared, but you can't see, and you can see a constant, but not an x. So here's an example. So I'm just going to basically work through all the different things that you might see when it comes to doing problems like this. So this one is 2x squared minus 50 equals 0. And you can tell there's no x term in there. And so we're just going to go ahead and build off what we know about solving linear equations and isolate the x. So I'm going to start by adding 50 to both sides. So I end up with 2x squared. Negative 50 plus 50 is 0, and 0 plus 50 is 50. And this, of course, is multiplication. So we'll divide both sides by 2. 2 divided by 2 is 1. So that would be 1x squared. 50 divided by 2 is 25. And then essentially what I'm looking for here is a number that when I square it will be equal to 25. Now here's where we want to be a little bit careful. I know that 5 times 5 is equal to 25. So I know that 5 squared will give me 25. But what is also true is that negative 5 times negative 5 would also give me 25, and that's negative 5 squared. So there's actually two answers to this. So when we go to undo the squaring, okay, so we're going to undo the squaring with the square root. Now, if you're not sure, like, I don't quite know what happened there, please go check out my video on what square roots are and how they are related to squaring. Okay, so this builds off of the previous knowledge. I am assuming that you've watched that video, you've covered that in your own math class, and you know how squaring and square rooting are related. related to each other. Now, if I do the square root to the left, I also have to take the square root of the right, but I need to put this in there, okay? And that symbol right there is read aloud plus or minus. But in this case, you might think of it as positive or negative. In other words, we're putting in a little symbol that is going to indicate that the answer to this could be positive or negative. Okay, like it could be either or. The square root of x squared is just x, and then the square root of 25 is 5. And so this particular equation has two solutions, and we would say plus or minus 5 or positive or negative 5. Now, if you're not sure, you're still like, I don't know, you're like a stranger from the internet, and I don't know if I trust you. We could always go back to the definition of a solution. We're looking for the values of the variable that will make the equation true. So if I go in here, and this was my original equation here, and I plug in a 5, okay, now we fall back on order of operations. Order of operations says we do squaring first. Okay, we'll do the exponent first. So 5 squared is 25. And then we do multiplication. 2 times 25 is 50. And 50 minus 50 is 0, and 0 equals 0, which is true. And the same check will work for the negative 5. So now you do want to be a little bit careful here. We want to make sure we put that in parentheses because we want to square the negative. Negative 5 times negative 5 is positive 25, and you can probably see where this is going to go. 2 times 25 is 50, and 50 minus 50 is 0. And so I get both of them making the original equation true. So that's pretty much the strategy. That's what it looks like. Let's go take a look at some other examples. The other examples should go a little bit faster for us. Now this one does not quite take the form ax squared plus c equals 0, but I can make it take that form if I subtract the 4 from both sides. So you might do something like this, subtract the 4. You could also subtract the 4 from like the left. Like in this case, it's going to land you in the same spot to try to isolate the x squared. 4 minus 4 is 0. And 4 minus 4 is 0, so I get 3x squared equals 0. Now from here, I'm going to pause for a moment and just see if you can reason this out. So 3 times what has to give you 0? A lot of students freak out the moment they see a 0. They're like, that can't be an answer. We can't have zeros. Yes, you can. 3 times what would give you 0? Well, that would be 3 times 0. Therefore, x squared must be equal to 0. And so what times itself would give you 0? It would be 0. But let's work through the algebra here. This is multiplication, so I can undo that with division. 3 divided by 3 is 1, and then 0 divided 3 ways, you still have nothing. And now we're going to take the square root. And in this case, I mean, you could put the plus or minus out in front. It wouldn't be wrong to do it, but also it won't mean anything. So the square root of x squared is x, and then the square root of 0 is 0. So if you put the plus or minus out in front, you've got positive 0, negative 0, but that doesn't mean anything. Like 0 is neither positive nor negative. It's not plus or minus 0. So there is just one solution to that. You do not need to put the plus or minus there. However, it might be interesting to just note that the plus or minus could come out of the work because of the way the problem was set up, and that might help you out a little bit later on, probably in Algebra 2, when you start talking more about like roots of quadratics and what they look like on the graph. Okay, so just kind of file that away in the back of your brain for much, much later. All right, let's move on to the next one. So for this one, we do have the correct form there, ax squared plus c equals 0. And of course, if you see something like ax squared equals like negative c or something, you have the constant on the other side, that's totally fine. Because what's going to happen is we're going to take that 8, and we're going to move it over to the other side anyway, so you can save yourself a little bit of time with that. So let's go ahead and move that over to the other side. We'll add 8 to both sides. So we get x squared is equal to 8. Now this one's a little bit trickier because there is no integer that squared gives you 8. So you think about, okay, well, we've got 1 squared is equal to 1, and 2 squared is equal to 4, and 3 squared is equal to 9, but we are looking for an 8, and 8 would be in the middle. So we're going to be looking for some kind of number that's in between 2 and 3 and is closer to the 3 than it is to the 2, because 8 is closer to 9 than it is to 4. So let's just go and see what happens. So we're going to take the square root of both sides. So we're going to undo that squaring. And we do need to remember that this will generate 2 answers for us, even if they're not particularly comfortable answers. Now, some people might leave it as just plus or minus the square root of 8, but going back to a previous lesson, 8 will factor into 2 times 2 times 2. That is a simplifiable square root. We're looking for perfect squares. And so we will have the square root of 2 squared, which is 2, and then we still have a 2 under the square root. And that would be your simplified answer there. So x is equal to plus or minus the square root of 2. Now, sometimes in a math class, you will want to simplify the square root. In fact, that's usually standard operating procedure in a math class. But there are times when you might grab a calculator, especially in a word problem, because if this has something to do with how many dollars you need, I mean, nobody's going to say 2 root $2. Like, I don't know what that is. And so you would grab your calculator and you might just throw it into the calculator. Now, the calculator is going to give you an approximation because 2 root 2 is irrational. The decimal is going to go on forever and ever and ever. And so you could throw that in there, and I'll round this to 3 decimal places, but it's 2.828. And of course, it's going to keep going. We use the little wavy equal sign to indicate that it is approximately equal to, and a lot of times we just don't even bother doing that. Just follow directions for what's happening in your classroom. Now, if you go back up here though, just to see if that answer makes sense, 2.828, well, it does make sense because we knew that the answer had to be between 2 and 3, and we knew that it was going to be closer to 3 than it was to 2 because 8 is closer to 9 than it is to 4. And that's not like one of those foolproof things that I would always be confident, because not everything is going to work that way, but it is reasonable. And if it did come out to like 2.1 or something, you might like ask your teacher about it and say, like, seems like this should have worked out this way, and it didn't. Can we talk about that in class? Okay. But in this case, like, it does come out to something that we think is reasonable. All right, last example, x squared plus 4 is equal to 0. So we're going to try to get that x squared by itself so that we can take the square root. And then what happens here is we get x squared is equal to negative 4. So this is going to be an issue because we can't take something and multiply it by itself and get a negative. Okay, and we'll just kind of re-reason this out. If you have a positive number, okay, so we'll use the 2. A positive 2 times a positive 2 will give you a positive 2. So a positive times a positive is going to give you a positive. A negative times itself, well, a negative times a negative also gives you a positive. And then the only number that's not positive or negative is 0, which will give you 0. And what you want to really be cognizant of, that means aware of, is that you are always going to end up with a positive. So if you have an expression or equation that says x squared equals negative 4, at this point, you're going to simply answer that with no real solutions or no real answers. Now, some texts might just say it has no answers, meaning there's no value of x that can make it true. I'm going to be a little bit more specific and say no real numbers. And in short, what that means is that none of the numbers on this number line, okay, nothing that we know of on that number line will work. But that doesn't mean that there might be some number that's not on that number line that we don't know about yet. And in fact, there is something that's not on the number line that you don't know about yet. So for now, just write no real solutions, and check out the Algebra 2 playlist for a lesson on what is an imaginary number. But that is not anything that we're going to go into here. So for now, just write no real solutions. Now, I want you to note this subtle difference. This is something that bothered me a lot when I was in school. If you are presented with the equation x is equal to the square root of 16, you assume the positive answer. So you assume that x is equal to 4, not negative 4. Okay, that is an assumption about taking the square root of something that we always default to the positive. However, if a similar problem were given to you, that is x squared is equal to 16, now we have this situation where you're going to solve that, and you do need to put in the plus or the minus, because the square root of x squared is x, and there are actually two different numbers that when you plug them in, could give you the positive 16. And when I was, I think, a junior in high school, something came up in my math class where I think I lost some sleep over this, because in my head, I was looking at the same problem, and it took like years for me to realize, oh, that's not actually the same problem. And I don't think any teacher ever pointed out the difference to me, that whether or not the original problem has the squaring in it is actually, like, it makes it a totally different problem. So it's similar, but it is not the same problem. So just note that this is one of those situations where, yep, you do need to remember that there was an x squared there, which means that you need to invoke that plus or minus to grab both of the solutions. Now, this is a very limited use strategy, since in most quadratics, b will be something other than 0. So it's not something that you can use all the time. However, when it can be used, it's a very efficient way to solve it. You can actually take all of these equations and you can solve them using other strategies that we cover in our study of quadratics. And sometimes we just go and default to those other strategies. But if you remember that this is something you can do, and b does happen to equal 0, then this would be a very efficient strategy for you. All right, please don't forget, give this video a thumbs up, subscribe for more math content, check out the practice set. I'll try to link that in the box above. It'll float up on the screen somewhere, but if I don't, or you miss it, just go to the description box and you can see the practice set there. And then check out the other videos we have. Drop a comment or question and let me know what you think. I will see you in the next video.